Yeah, so this is the presentation of the Tower Herculids observation campaign from the ground and from the air. So there was one big expedition by the Slovak team. So some of them are here, I guess. And also from the national team in the air. So it's all about the Tower Herculids, and that's the nice logo for the whole campaign. Oops. I'm not working. Yeah. Yeah, thank you. And obviously there were lots of organizations. So University of Bratislava, of course, some local people in the US, RTI, who funded the airplane campaign, and some people from Germany, us from France, and so on. So thank you to all the sponsors. Okay, so it all started with Comet Strassmann-Wachmann 3, so 73P. It's a Jupiter family comet. The orbit is quite well known. It's, I would say, a regular comet that goes from the Earth up to Jupiter. The period is more than 5 years. And in 1995, the comet broke up. It was observed from the ground, and so in 2006, when the comet and all the fragments were making it back to the perihelion, there was yet another outburst. So the main fragment did fragment again. So this image was actually taken by Spitzer, and so you see fragments B and C, and all small fragments here. The thing that is exceptional about this image is that you can actually see the meteoroid stream here. So it goes along the orbit of the comet. In visible wavelength, you actually never, ever see that, just because, well, the particles are just too small to reflect the light of the sun, and they're too big for the diffusion. So this was taken at 24 microns back in 2006 by Bill Reach with Spitzer, and really that's an incredible image. So in order to put things into context, the idea is to compare the Tower Herculids to another meteor shower that was caused by another comet that broke up in the past. And one famous example is the Andromedan meteor storms in the late 19th century. So the parent body was Comet Biela, that is D Biela, D as in disappeared. So it's basically a comet that you can no longer observe again. So there was a breakup of the comet in 1846-47, and a storm in 1872. So the ZHR estimate for those storms by Philip scans were a few thousands based on the reports back in the days. Now, of course, the reduction process was not the one that we know today, so we should be cautious about those numbers, but the bottom line is that those showers were big. And if we compare the circumstances for the Tower Herculids, it's very similar in the sense that, okay, these are two Jupiter family comets that broke up, and the meteorite stream makes it to the Earth a few revolutions later. So now the big question that we had was the following: okay, this is the orbit of the Earth, orbit of Jupiter, and the red dots, the comets, and this line here is basically the meteorite streams ejected during the 1995 breakup of the comets. If the particles were ejected at twice the regular ejection velocity, and under those circumstances, basically the stream doesn't make it to the Earth. So if their ejection velocity is only twice the ones that we used to, but then there is no meteor shower expected at all. But if the factor is 2.5, well, then yes, we will see something. And now the question is, well, what was this factor during the outburst? The real answer is we don't know, okay? we're not even sure if the model that we have for to compute the detection velocity is 100% correct. So what happens during a comet outburst? I mean, come on. To be very honest, well, we're not 100% sure. It's likely, it's not crazy, but the truth is, well, we're not 100% sure. Now, again, considering this high ejection velocity, see, these are plots very similar to what David Asher did a few years ago for the Leonids, and Joe Rao also published such graph. So that's the path of the Earth, and we can see that, yes, under special circumstances, the Earth encounters stream injected in 1995. But again, there are conditions for that. If we compute the theoretical gradient, it's quite far from the usual typical tower Herculids gradients, and also the date, not that the regular shower. The reason is that basically the stream is unusual one. So now the next question, in order to organize an observation campaign, is where to go, where's the ideal location. So the subgradient point is over Baja California. So basically California, Nevada, and all the southwestern states of the US are very good. Mexico as well. Even Central America would not be bad. Chile is not the perfect location, and I'm not talking about Europe and even the Canary Islands. That's far from being optimal. So that's why, as you already heard today, some of us went to North America and towards the west. Okay, so here's an example of the setup, and so if any of you have never been to any observation campaigns, please go some of these days. Yes, sometimes it's small, not always, but basically you're gonna have a fantastic view. So the ground stations were in southern in the southern part of the country, and this is the trajectory of the airplane. So basically taking off from Dallas here. If possible, the plan was to have both ground-based observations and air-based observation. So Juraj and his team have a lot of different instruments: wide field of view, all sky field of view, narrow field of view, spectrum capabilities or not. So basically, when you go on such a campaign, you pack up all your toys. That's how I like to call them. And the locations were chosen so that at least double or triple station observation are possible. And by doing so, well, you have the 3D trajectory. You can derive the tensile strength. You can measure the orbit. So basically, you make the most of any observation campaign. Of course, there was the Amos cameras, and the Amos spectral cameras. Again, narrow field of view, wide field of view. Amos is all sky. Obviously, those guys had a lot of fun. Okay, and they detected more than 400 tower Herculids meteors just from Amos cameras, so several hundreds in total. And obviously, the sky was fantastic. There will be a movie after the presentation of show all of that. Actually, there were bushfires sometime. Minor 13, minor 2. That's good. I wasn't there. I cannot comment, but I think it's pretty obvious what happened. Okay, and on parallel there was this air-based campaign that was funded by RTI. So basically, this guy really wanted this campaign, and we were extremely happy with that. So again, the flight plan was supposed to go between the ground-based stations. So Juraj stations were here. There are some amateurs here and here. So we were basically going close to the station, but not above the stations, in hope that we will have multiple station observations. So we went this way and then we went back there. So the first thing you do for an airplane campaign is that you put the cameras into the airplane and you really pay attention that you do not scratch anything, because otherwise it's going to cost you an arm and a leg to repair. So the airplane is Phantom 300. It's a small airplane. You cannot stand, well, somebody as tall as me cannot really stand up in the airplane. And the windows are about 20 centimeters wide, and you want to basically put as many cameras as you can. No, you don't want to open the window. Or you do it only once. You do it after the observation, please. So every one of us tried to squeeze as many cameras as we could. So on the left is the Juraj settings. In the middle was Fab settings. On the right, that was my setting. So two of the cameras were stabilized and two were not stabilized in my case. I'm going to talk about this later. So timing is everything. Like, you don't want to miss anything. So we had a rehearsal flight, and good for us because we realized that the takeoff timing was wrong. Like, because of the time difference between Arizona and Texas. Anyway, long story short, the rehearsal flight was mandatory. And I recommend that there is always test flights. Basically, we also had a lot of fun. So inside the airplane, you see it's very tight. Yeah, you don't want to mess up with the instruments and with your neighbor's instruments. That was the night of the takeoff. We were all very happy. I was super stressed because I told everybody, guys, you understand, we might not see anything at all. Yes, we understand that. Okay. And the tower Herculids showed up. What a relief. Yeah, so Juraj was counting the meteors by naked eye, just looking by the window, and also Fabs was counting the meteors just looking at his screen. And Juraj told me once we landed, yeah, I had the impression that the ZHR was as high as 300, which obviously is not what people saw from the ground. Now, we know from theoretical works that the number of meteors that you observe from an aircraft should be higher than from the ground. The question is how much? And 5? Yep. My own answer is, so for the people on video, Detlef says 5. My own answer is, well, we should double check that. My latest theoretical work with stratospheric balloon basically disagree with some observations. Anyway, that's some work in progress, but we will talk it. In the next presentation, I'm going to show you a cluster of meteors. So there was basically 34 meteors within 7 seconds. From unstabilized cameras. Yeah. So Stefan Loehle detected some meteor spectra with a Sony camera. There were some spectra also recorded with Juraj's cameras. And from the spectra, we can infer the fact that there was a lot of sodium, magnesium, iron, and some traces of chromium in the tower Herculids, which in a sense was expected because it's a cometary meteor shower and low velocity. But still, it basically means that these meteoroids were never hit so much. And thank you very much.